can make your data useful to others without actually letting them have access to it. There are ways to do this, ways to make knowledge from the data accessible or the existence of data knowable. And that's what this talk is about. Cafe Variome is not a database, it's a menu or a shop window. It's a discovery interface. The platform enables data custodians to specify which of all possible users can search for and then display counts of, or display even some of the data fields of, which subsets of all the records and which of the record fields for those records are displayed using whatever set of search parameters they want to use. So you can see on all levels, on all dimensions, it's flexible. It leaves the data custodian in total control of who can get to what data under what circumstances, whether at count level or individual data level. Down here shows the 3 levels of data return. Let's say result return. It's not the data that's necessarily being returned. You've done a query, and this is what the system will tell you. It will say, you found some records, and for you, they are listed as open access. So here you are, you can go and get the data on those. Or it might say, no, you can't have the data sets that you've hit, so you can't have them, but here is a URL, or here is an email, or here is a phone number if you want to contact the data source to request the data. The third option is a box pops up for you to request the data. You press go, it sends an email to the data custodian, data owner, who then will consider your request and decide what, if any, of the data to let you have. And that will also be handled by the system automatically. Often you'll want to make a more precise search, so we've built an interface for that. We call it a query builder. And you can see you can search by DNA features, by gene symbols, by HGBS names. These are just labels that uniquely specify positions and genetic changes in the genome. Or by phenotype. Any kind of phenotype data that is stored in the system being searched. Here is an example of a phenotype-only query where someone's asked for subjects whose age is greater than 64, where this ApoE, a risk genotype for Alzheimer's, where they have 2 alleles, no more or less, so it's equals to 2, and where the gender is male. So you get a sense of the flexibility of the system. The system, for you to enter a query on phenotype, you need to know what possible phenotypes exist in that resource. So the system gives you a pull-down list of all the options that you can search on in that resource or collection of resources. You need to use the right words in your databasing and in your searching. It can be connected to available public ontologies, or you can have your own local list of terms, and those are then, the system then constrained to using terms from those ontologies or vocabulary lists when putting in data and when searching for data. So it tightens up everything so you know what you're getting is what you want it to be. The whole point of this system is that you're now, if you think about it, searching for discovery on the data. You're not searching on some higher level concept like metadata or a description of the resource. This way you're searching on the data directly, so if you get a hit, you know the data truly are useful for you. It's then worth the effort of requesting access. The way the system can be set up, you install the same software wherever you are, however you want to use it, and then you adapt it to your needs. You could set it up in a network where one of the installations becomes what we call the head node. So this would be the place you go to do all your searches, and it just passes those queries on to the other installations in other places in the network. Or more typically, it would be set up in this kind of all-to-all arrangement, where each of these becomes a search interface for any or all of the others. And each site decides which of the others it will allow to search in its system. So you can see it again is very flexible and leaves all the control with the data custodian. To enable all of that flexibility and that functionality, there clearly has to be an administrator interface, and there is that. It gives you lots of options, including full logging, ways to look at the statistics and how it's been going and so on. Lots of tools all around that, and ways to set up your data so that it has the protection you want. The other tool is what we call Omics Connect. In many ways it's similar, but it's different. Often people say to us, I want to look at all my omics data, not just GWAS data, and I want to look at all my data and my collaborators' data in the context of public data. How can we do this? And the answer is, well, you can't. So we built something to enable that, and that's what Omics Connect is. So it is a browser that allows you to look at, to mine, to explore omics data. And if you notice in this browser display, over on the right there, some of the data is local data, Some of it is remote data. So this is not only a way to bring omics data together and view it from lots of different places, local and remote. It's also a way to look at various data in a controlled manner, control who in a network can see which aspects, or even which sections of the genome for your data. The gatekeeper, the way that's all managed, is a tool called EDAS. DAS is just a technology for feeding these files to a browser. We've enhanced it to bring in new types of capability and this control of access to that function. So EDAS now exists, and if we look at how all that hangs together, so this is the user looking at the browser. To look at a browser screen, you could either be a local person sitting in front of the computer, or you could be some remote site somewhere else logging in and looking at that browser. Of course, that browser can be pointed to lots of online resources for genomics tracks, but the stuff we've built with Omics Connect is here. These are the raw data files, the local databases, the online resources from your collaborators and so on, all being managed and access controlled by this EDAS system in the middle there. And of course, that EDAS system could also push the data out, not to this Omics Connect browser, but to any other browser out there on the web. So it's aggregation of data for collaborative visualization and data mining with controlled access built in. Omics Connect is the most new of the tools, and that's now being explored in Cyprus, University of Cyprus. They've got a big biobank there. But Cafe Variome, it's being used in various contexts, in national diagnostic lab networks, global rare disease consortia where they've got particular interest in one disease, and in situations where I call it subject selection from cohorts for clinical trials. So those are the kind of context that it's being used in. So if you found any of this stuff interesting and you'd like to find out more or adopt these tools or collaborate with us to further develop them, please get in touch. My email address is ajb97@le.ac.uk.